Hi, this is a little lecture over transformations, section 3.5. There is another problem on 3.5 that's already on the YouTube, but I decided to give you a little lecture, probably around 4 to 5 parts. This is part 1. I am doing this at my home, and so the board's a little smaller than you might be used to that's in my office. But anyway, this is 3.5. Part 1, the definition of a transformation is the movement or the distortion of the shape of a graph. Now, I'm probably not going to find that out of the book. It's just basically you're given a shape, and it's called what I call it the parent graph, or the book will call it the basic shape. Um, and there are many different types of transformations. There's 6 that I made a little outline for you. And you will be using these in combinations of each other. You may have them stand alone, only one transformation, but you may have multiple transformations. And I'll do a problem that has 3 to 4 transformations in my last part. But this first part, all I'm going to do is identify what the transformations are and the basic shape that we're going to use. So the types of transformations are the vertical shifts, and that means getting a graph and moving it up or down, depending on what the number is that makes it happen. Horizontal shifts are shifts that will make it go left or right. So in the 1 and 2, the shape of the paragraph is not changed. It's not distorted at all. It's just kind of like what I call copy and paste. So you take the basic graph, and if you move it up and you don't change it at all, it still has the same shape. It doesn't become distorted. So it's just a movement up, but still it fits the definition of transformation. It's the movement. Same thing goes with the horizontal shifts, left or right. Vertical reflection is not a distortion either. It's also the movement of a graph, but this one is to copy and just basically turning it upside down. And then there's a horizontal reflection, which also is not a distortion, and it just flips across the y-axis. So a vertical reflection will get it up like this and just turn it upside down, and a horizontal reflection will take it and then do it to go this way across the y-axis. So instead of like this, it will, and on a vertical reflection, will go upside down. So that's the idea of the reflections. Then there's the vertical distortions, and this is what I call the stretching or the compressions. And the stretching is when you have a scalar out in front that's more than 1 that is being multiplied by the parent graph. And the compression is when it's less than 1. Those are the vertical distortions. So on a distortion, it doesn't change the shape of it per se. It still has pretty much the same shape. It's either going to look skinny or fat, but the shape is the same. It's kind of looking at yourself in a mirror at one of those crazy museums that has those mirrors. You can still tell it's you, but you become really long or really short and compressed, but you can still tell it's you. So that's a distortion. A horizontal distortion is stretches and compressions as well. So we're not going to be talking about those so much. That's why I have a little asterisk beside number 6. And so this one right here we're not going to talk about, but that is another type of distortion. But that's a horizontal one. Now, the basic shape we're going to be using is just a regular parabola. I could be using anything else with this one. As a matter of fact, my other video that I have with this one is using the x cubed graph. So I'll send that link too. Or you can just go like you usually do, just find 3.5 transformations, and you can find the other one as well. So, but anyway, this one's going to be a full little lecture over this. So now part 2 is going to cover basically 1 and 2 on the 1 and 2 here, and part 3 will be 3 and 4, and the next part will be part 5. And the next part, if I can't put it all on the next part, I have an extra part that will show you one that has all of them. So if you're going to look at any of them, the last part is probably the best one to look at. But what I'm doing is on the individual parts, I'm leading up to the grand finale. So I'm going to show you 1 or 2 shifts, and then the last part will have like 4 to 5 transformations being applied to it. So that's the most important one. If you look at any of them, that's the one to look at. So, all right, I'll see you in part 2.